Hi, we're the AI networking team, and this is our final project presentation.
So the project we have been working on over the past summer is a measurement study on whether websites send private user information to content delivery network, which could be a security issue. So before we start, we have to understand what a content delivery network is. In essence, it is a geographically distributed network of proxy servers and their data centers. As you can see in this graph, users will communicate with the cast server instead of communicating with the origin server. And as a result, it will provide high availability and performance by distributing the service spatially relative to end users. And additionally, it can also reduce bandwidth cost and improve page load time, since users are way closer to the server right now. And as there are multiple targets, it can also, in some extent, prevent distributed denial of service attacks. However, there's some security issue with content delivery network. Under the current model, if a website chose to use the CDN, then it can have access to all information exchanged between users and the original server, including sensitive ones such as user's password or the user's bank account. So if a CDN server is compromised, then user's password might get leaked, especially when this content delivery network server leaked the private key of a website, which is disastrous because other evil people can use their private key to fake as the owner of the website. So in order to reach our goal of conducting a measurement study, we have to detect if a website sends private information to a content delivery network. In order to do that, we divided up into 3 steps. So the first one is to create an automated login script to send user information. And we will spend most of our presentation discussing it. And the second step is to capture the login request and identify which server the password is sent to. And finally, we'll check whether the server belongs to a CDN or not.
In order to create an automated login script, the most important challenge is to identify the correct buttons. If you see the New York Times homepage, there's a subscribe now button and a login button. What's wanted is the login button, because we need to be able to send user-sensitive information to the website to check if it uses a CDN or not. So if you look at inside the login page, there are 3 other buttons that's really important: the email button, the password button, and the login button. So first of all, the most important part of our algorithm is to detect or classify if each HTML button is an email address, password, or submit. So then if we were able to, assuming that we were able to detect the buttons, we would take our homepage to the login page and repeat the process until there's an email address or a password address that we can enter. And then if there are those inputs, we would enter those fake emails and fake passwords and then log in to see where the sensitive user data information is sent. There are 2 methods that we used, the machine learning approach and the human curated algorithm approach. The machine learning approach is flexible because we can switch models and improve the models as we go on. And we were also able to find out hidden rules. For example, which strings or which set of words were most used in a certain button, things like that. For example, the password button had the words password and PWD mostly used in the HTML code. And another method that we employed was a human-created algorithm. Because we were able to think from a developer's perspective on logging in, so let me get into more detail on how we use machine learning to classify the HTML buttons. We first used data preprocessing to crawl 100 websites and manually classify an HTML into the 5 classes, which is user, password, login, submit, and next. And we first used a unique feature vector with a unique set of strings that each HTML had, which led to overfitting and too much computation time because there was too much feature selection. So we decided to decrease the amount of features actually used inside each model. And if you look at each HTML code, the features are the element tags, for example, input, or A tags, and the inner text data, for example, login, submit, and the attributes data, which contains the values or perhaps some hidden fields inside the HTML. So we created and tested 4 models: the naive-Bayes model, the linear support vector machine model, the random forest model, and the softmax voting classifier model, which basically combines the 3 models before and then votes upon the softmax equation if this should be classified into which button. So sharing our results, the random forest model was performing the best with the accuracy of 0.92. The second best performing model was the linear support vector machine model, which had the accuracy of 0.9. And so we decided on to go with the random forest model. And in order to optimize the model, we did a few tests to see which features were most relevant in order to classify the buttons. And the way we did it was to determine how many times should a certain word appear in order to be selected as a feature. The best performing model was the random forest model with the minimum number of feature frequency size of 113, which had the highest accuracy of 0.92, as shown in the right graph. So what that means is that a feature is selected only when it occurs in the sample trust data set more than 113 times. So these are the final features that were selected. And the relative importance of each feature is also calculated using permutation. And then let me show you a quick demonstration of how our script works. So as you can see, it creates a Chromium driver, and then it loads the URL of the web page that we're trying to see, and then it automatically translates it. And then if you see at the top, it selects the login button and then presses it. And then it tries to find the username and password. And then the network request is sent, and we use it to determine if the website uses a CDN or not.
We have employed some tricks in our automated locking script, and the most noticeable ones directed against Google's reCAPTCHA, which is especially annoying because it is designed to prevent bots like our script to access the resource on the website. So in order to resolve this issue, we created a fake version and redirects the Google's reCAPTCHA install request to the fake version we created. That fake version mimics the behavior of the genuine one, so our script can submit passwords correctly. Note that we created a fake token, which will not pass the check on the server side, but since we only consider which server does this password go to. So this fake version serves our purpose well. So that concludes our first step. And the second step is to capture the login request. We use a randomly generated password that is unlikely to be any data on the page. After we click the submit button or the login button, we check every login network request and identify if it contains that password. Then we get the URL of the request and we resolve it into the IP address using DNS service. And that leads to our final step, which is to check if the server belongs to a CDN or not. So we use something called registration data access protocol to check who owns the IP address and compare the company with non-CDN provider. So after we get the IP address, we'll look it up using RDAP protocol, which will give me the information of who owns the IP address, which in this case is Fastly. And we have already known that it's a famous CDN service provider. So we conclude that New York Times is sending my password to a CDN.
The final result of our project suggests that higher ranked US sites are more likely to use a content delivery network, and lower ranked websites use less content delivery networks for sensitive user data because they might not have login feature implemented. And according to these two models, the final model was created to detect if websites use a CDN or not. This is the combined rule ML-based methods for US sites. Because we're using a list of CDN based on US sites, we only consider content delivery networks that is based on the United States. However, even if we employ our same algorithm and method to global sites, the trend is the same. If we implemented more CDNs on our CDN list, then the percentage of CDN usage would go higher, and the accuracy of our script would be higher. These are the comparison of the two methods that we used based on detecting if a website is using a CDN or not. As you can see, the rule-based method has a higher percentage of detecting if it uses a CDN or not. And the machine learning methods has a lower percentage of detecting if a CDN or not. However, what's interesting is that there are some websites that only the rule-based methods detected, and in some websites that only the machine learning model detected. So by combining those two models, we created the final model and the final result of providing the lower bound for the percentage of content delivery network used for US websites. In order to determine if both of our scripts were actually logging into pages which had a login script, we random sampled 100 websites and created a confusion matrix. And as you can see, both models don't have any false positives, which is good. So the precision rate is 1. And also the problem is with recall. And improving the recall means that we would actually log into more and more websites that actually had the login button, which means that improving the model would be able to detect login buttons better and thus log into more websites, improving the accuracy of both of our models. Further research would be to improve the rule-based and machine learning-based methods, and also to identify which CDNs most and least expose sensitive information. And that is our final project. Thank you.